Today we're going to be talking about how to find the linear function f of x, given that f to the negative 1, or the inverse function of f, that f to the negative 1 of negative 3 is equal to 8, and that the inverse function of f at 4 is equal to negative 7. So essentially, we've been given 2 points that are on the line that is the inverse function of f of x, and asked to find the original function f of x, knowing that f of x is also a linear function, so meaning that it's a line. So what we need to recognize is that when we're talking about inverse functions and f to the negative 1 of x is the inverse function of f of x, when we're talking about inverse functions, an inverse function is the same as the original function except with the x and y variables flipped. So if our original function, for example, is f of x equals x squared plus x plus 1, right? We can say that this is essentially y equals x squared plus x plus 1. And the inverse function of this function here would be the function where we flip the variables x and y. So in place of y, we put x, and in place of x, we put y. So we'd get x equals y squared plus y plus 1. And then we could simplify this function in different ways, but essentially we're just talking about flip-flopping the variables. So in this particular problem, where we have 2 points that are on the line that's the inverse function, we just need to go ahead and flip the values for x and y and call those points on the original function. So we have here on the inverse function the point negative 3, 8, and the point over here on the inverse function 4, negative 7. Well, on the original function, we would have the opposite case. So we'd have f of 8 is equal to 3, or in other words, negative 3, or in other words, the point 8, negative 3. And over here, we'd have f of negative 7 is equal to 4, or in other words, the point negative 7, 4. So essentially, in our original points that we were given, these were points on the inverse function, and we had the x and y coordinates. To find the corresponding points on the original function, we just flip-flop the x and y values, and we have these new coordinate points that are on the original function. So now that we have these 2 points, we can easily find the equation of the line from 2 points. And remember that the equation of a line, and we'll use the point slope form for the equation of the line, is y minus y sub 1 is equal to m, the slope, times x minus x sub 1, where x sub 1, y sub 1 is a coordinate point and m is our slope. So in order to solve for m, we'll just take the y value here, negative 3, and subtract the other y value, 4, and divide that by our first x value minus our second x value, negative 7. When we simplify this, negative 3 minus 4 gives us a negative 7, divided by 8 minus a negative 7 is 8 plus 7, which is 15. So now we have m equal to negative 7 over 15, in other words, a slope of negative 7/15. So now we have a slope and a point, and we can say y minus, we'll use the point 8, negative 3. The y value in this coordinate point is negative 3, so we'll say y minus negative 3 is equal to the slope we just found, m, negative 7/15, times x minus the x coordinate from our point, which is 8 here. And keep in mind, we could have just as easily used the point negative 7, 4 and gotten the same result. It doesn't matter which point we use now. So we plug those in, and now we simplify. So we'll get y plus 3, because we have that double negative, is equal to negative 7 over 15 times x. Now we have a double negative again, negative 7/15 and negative 8. When we multiply those together, we'll get positive 56 over 15. We can find a common denominator with the 3 over here, so we'll say y plus 45 over 15 we multiply that by 15 over 15, and we get 45 over 15. Notice that this just simplifies to 3, but we have a common denominator with the terms on the right-hand side. So we have equals negative 7/15 x plus 56 over 15. And now we can subtract 45/15 from both sides and get y equals negative 7/15 x. When we subtract 45 from 56, we'll get positive 11 over 15. So this is our final answer. This is the linear function, and we can even, since they asked us for f of x, we can go ahead and give the notation f of x, but this is the original linear function, and if we took the inverse of this function, we would get our inverse function and find that the points -3, 8, and 4, -7 were on the inverse function, the line that is the inverse function, but 8, -3, and -7, 4, those inverse points are here on our original function. So this is the original function f of x given 2 points on the inverse.